So the second feature of graphs we're looking at is called concavity. And we talk about a function being concave up or concave down. So concave up is if the curve is curved upwards. So if you draw the tangent line, it will be below the curve when it's concave up. So like if I draw a tangent line, it will always fall below the curve when it's concave up. The slope of the graph is increasing if f of x is concave up. And sometimes this is really hard for students to wrap their mind around. But if I look here, my slope is a very steep negative number. So it's a large negative number. And then as I get closer and closer to that turning point, the slope is less and less negative. And so that means when it's like, if I would estimate and say, okay, the slope is like -7, and then it's -5, and then it's -2, and then -1, and then 0, these values are all increasing. We're going up in value. And so the slope is increasing. And then when I get the positive, it's easier to see because it's getting more and more positive. So the slope here would be like 1, and then the slope would be 2, and the slope would be 3. And so this slope is increasing. Okay, we're looking at the value of the slope, not the y value. And that's the hard part about this. So I'm saying the slope at this point is like -7. The slope at this point is like 3. If the slope of the graph, if the second derivative tells us concavity, so if the second derivative is greater than 0, so if the second derivative is positive, we know our function is concave up and the derivative is increasing. So the second derivative is the derivative of the first derivative. So you're taking it twice. So you're finding the slope of the slope. And when that is increasing, our function is concave up. So this is concave up and my function is decreasing. And this is concave up and my function is increasing. Okay, but the slope in both of these is increasing. Okay, and it's really hard to wrap your mind around slope versus just looking at whether the original graph is increasing, decreasing. Okay, so concave down is if it's curved downwards. If you draw the tangent line on anywhere on these curves, it's going to fall above the curve. The slope of the graph is going to be decreasing if it's concave up. So again, the slope is very steep and it's a big positive number like 5. And then as we keep going, the slope is getting less and less till it gets to 0. And then it's going to get more and more negative. So like -1, -2, this is like -3. Again, we're talking about the slope, the steepness. And so the slope is always decreasing when it's concave down. So in terms of derivatives, the second derivative is less than 0 when it's concave down. And our first derivative is going to be decreasing. F prime is decreasing. Okay, so one way to remember, this helps you great. If not, don't worry about it. But when you're happy, Mr. Smiley, he is concave up and your second derivative is positive. When you're unhappy, Mr. Frowny is concave down and your second derivative is negative. So then we have this thing called the inflection point, and an inflection point is where the concavity changes. It changes from concave up to concave down or vice versa. At an inflection point, the second derivative is 0 or undefined. Again, in this class, we're mostly going to do that the second derivative is 0. And the second derivative must change sign. You need to check that. There's cases where it will not change sign, and that's not an inflection point. So when we talk about the derivative, what's going to happen is that the derivative is going to change from increasing to decreasing, or vice versa at an inflection point, and the derivative will have a max or min at the inflection point. Okay, so we know that at an inflection point, the derivative is the slope, and so the slope will change from being like increasing to decreasing at that inflection point. Okay, or vice versa. So that is where you have a maximum on that derivative. So just kind of to summarize it, if my function is concave up, we know that the second derivative, f double prime, is positive. And we know that the first derivative is increasing at that point. The slope is increasing when it's concave up. When it's concave down, the second derivative is negative, and we know that the slope is decreasing. Okay, and because it's decreasing, then the slope of that, which is the second derivative, is negative. At an inflection point, we know the second derivative is 0 or undefined. Again, we're mostly doing 0. And this is going to be a max or min of the slope. Okay, so that is what concavity is and the relationship between the first derivative and the second derivative.